Hey everyone, welcome to another Truth in Life Tech Talk. I'm Johnny Sanders, and today we're going to discuss a, AWS architecture design that I put together, and I just want to share with you what I was able to accomplish and do, and give you some tips. And this is going to be an AWS architecture design using big data. Okay. Ah, Oh boy, getting set up here. So, anyways, so hit the like, hit the subscribe, and let's get going. And please share this video so we can help the rest of the world, okay, if you will. So, again, this is an AWS architecture design that I did with big data and data ingestion, storage, and items like that. So we were working on a specific project and a task and for the company that I was working with. And we needed to do some ingestion of data and preparation. And so I had to actually build a team to be able to help and manage me perform all of the tasks. And the team members were, excuse me, data engineers, app developers, data ops engineers, data scientists, data analysts, to basically help me with putting together a plan, a roadmap, um, making sure that things were going to be scalable, streamlined, visual data flow that was going to necessarily be put in place, having something to be able to manage, edit, monitoring the health of the monitoring of specific applications, um, being able to do quick and easy uh, metadata search. So we would need to just have a lineage of statuses and just scalability items that was going to be able to work with us. So one of the things that we want to do, I want to make sure that we were able to capture and store the data from various sources to make this a feasible, profitable, beneficial, scalable project, right? So I was going to need to make sure that, from my perspective, the things that I've worked with is IoT devices, databases, web apps, third-party APIs to be able to bring this information to the team, business owners, business managers, application owners, so they would be able to easily see this. So, in the data ingestion, some of the tools that I basically wanted to work with was AWS Kinesis, Apache Kafka, Google Pub, Subreal Time Data Streams, Apache NiFi for batch processing, data storage. We were going to definitely use Data Lake and some Amazon S3 buckets, right? And some storage was going to be utilized with a mixture of Google Cloud and maybe Microsoft Azure Data Lake storage for raw data storage. And these are just some of the items that I presented that we was going to just hammer out and make it easy and breezy for everyone that's involved, right? We was gonna definitely need a data warehouse like Amazon Redshift, Google BigQuery, or Microsoft Azure Synapse, which is an analytics tool to help with structure and processing the data. Okay, so from an architecture design, getting to setting up and preparing for the AWS aspect for the big data, what I would say, want to first start off with data sources. As I mentioned, the IoT devices, right? Internet of Things, your phone, your tablet, your laptop, your computers, right? Um, to be able to use and communicate to the databases and use to uh, um, move data across APIs, the URL, to make data ingestion easy. this would go to the Kafka and the Kinesis, where the data would be also pushed to data lakes, and it would go into our S3 bucket, which data would go from our S3 bucket to our data warehouses, Redshift, and our BQ and Synapse, right? So this helped start laying the groundwork and the process flow of how uh, I envisioned with the team that this was necessarily going to need to take place. So other tools that um, I believe, because this is a large project, it was going to be ETL tools, and this is the ETL I've mentioned: extract, transfer, and load. Right. So this is basically taking data, uh, specifically if there's batch, which I believe there are batch projects that a lot of companies are using. For us, I knew the batch price processing was a factor, and the ETL was going to be able to take those batches, take them and push them to an ETL processing unit, which was going to send it to our database. And basically, it would come in, the batch processing would come in one format. It would go into the ETL. It would get configured to one easy streaming data, and then sent out to our database in S3 buckets. Another thing that I want to be able to implement is Apache Spark, AWS Glue, Google Data Flow, and again, Microsoft Azure for data factoring, right? And this was going to be a whole data transforming process, which was going to be, again, which the batch processing will be connected to scheduling. Okay. So it won't be going into the system, into the database all at one time and flooding it or overflowing it. Um, we want it to be clean and concise so that data, large amounts of data, could come in at specific times, especially data that may have just been processed and may not necessarily need to be looked at until a few hours. So it would be scheduled, right? And your engineering team can schedule that accordingly. Real-time data processing um, for immediate insights would be available in this process as well. So you would set the schedule according to what you need, what the business need, and those specific requirements. So in this particular data flow, using big data coming into AWS, um, using data lake, S3 buckets, right? And again, going into the ETL tool, getting processed into the data storage via S3 buckets. Okay, this would help with the visual data flow, um, and making it user friendly for our users, you and I, not behind the scenes, but actually the users that's requesting specific information. This helps with managing the data flow and data processes. So with the data flow, data processes, um, we wanted to make sure that we had a number of items in place that would help us. And so the finished AWS data flow and process of this specific project that I just went through on some of the other items, what we're able to do was have a good, clean process flow using AWS, right? So I want to talk specifically about that part of it. And, we'll get to the machine learning a little bit, but again, this is all big data going into um, a database, making it easy for end users to basically grab data, perform the tasks that they need to be able to perform, and then um, going on to the next one. And of course, we as engineers, you have alerts and checks, monitoring of a system to make sure that it's working and performing the way that you would have it to perform. And so I would say do monthly checks, monthly maintenance updates, just to ensure that your data has no issues, has no hiccups, nothing is slowing down, there's no bottlenecks. Even though you have alerts to check, um, everything is going good, everything is moving and flowing the way that you have it designed. I would still do a monthly check just for sanity's sake and to be able to communicate to management um, and stakeholders on a monthly basis. Okay, so one particular project that I want to just really focus in on is the AWS Flow. Again, this is big data. You want to start with having your Route 53, which is a DNS server, right? Basically, this connects the user's requests to the internet applications running on AWS, or if they have an on-prem services. On-prem are still bare metal, actual physical servers. The old school boxes, some of them new school boxes, but the boxes that are still on site. So data would basically submit a request from the user. Route 53 DNS service will basically connect and grab that request. The CDN, which is a CloudFront, will basically take that data and um, take it and distribute it across the network. Sorry about that. I was thinking of two things that possibly could have happened, but I don't want to convolute or confuse you. So I'm going to stick to the clean version, right? So the CDN would take that data and send it through the network to be able to provide, a global visual of the distributed items, distributed data across the network of proxy servers to also be able to cache content, right? This would also be able to be done using CI/CD Jenkins, which is a plugin. It's a sweet plugin that basically takes codes from a developer that has been programmed. It takes that code and basically sends it across the data in the network to be implemented and integrated across the pipeline. So there's a continual integration. So the system, when a request comes in, may go to GitHub to get the code, um, but it should automatically be within that process. Um, and if it's not, then it would need to be programmed to go and grab a specific program language to say, hey, take this data and submit it to the next instance. The next instance process within this AWS process is AMI and EC2. It's an AC2 instance. AMI is Amazon Machine Image, right? And so it takes these uh, data instances and pushes it across a virtual server in the cloud. Its configuration uh, process launches a copy of the Amazon machine image to a specified uh, place, area, instance. Okay. One of the things that is set up in these instances was AWS IAM roles, right? So the IAM are basically um, for security setting up. And so these roles are set up on something called a subnet for availability zones. And you need to make sure that this is set up properly, because if not, users and their roles and permissions um, may prevent them from logging in or getting access to certain databases or access to certain S3 buckets. And they need to make sure that their access is set up properly. Now, being transparent, I had a little bit of an issue um, once before that I want to share with you to make sure you understand that things happen, but there's a fix for it. One of the things, I didn't have a primary key. I need to make sure that I input the primary key in a specific user's role. Second, there was a profile issue that wasn't set up properly, and so what I had to do is call and get an instance profile from AWS to help me with setting up or fixing the profile. Um, there was an empty instance profile um, that I didn't see or know at the time. So if it's empty, that will cause the user's access to fail, and they'll get some type of message like access denied error. So the quick fix was um, you go into the coding in the effect, allow action, I am, pass role. Okay, I am, pass role. Resource, the ARN, AWS IAM, whatever your specific role and title is, or name that you've given it. Uh, that was the fix. Now, for the users, according to what your IAM permissions role is, everybody else role, and again, that's more of an admin or power user. For those that don't necessarily need to do any type of admitting, then just give them read-only access in the database, okay? So from there, I know that was a lot that I just gave you, but that I just want to share that quick fix in case you need it. But from there, uh, data was sent to the S3 bucket. Again, that's where the data is stored, uh, configured, utilized. Data logs are there as well. They get generated, so you can go to the S3 bucket and get those data logs to see if there's any types of uh, issues or alerts, or if there is an alert, you go to the S3 bucket and get the data logs to find out what is happening, right? So then data will go to the app ELB, which is an elastic load balancer. This happens automatically, and it distributes data from the application. Um, it brings the data in across multiple availability zones of available uh, companies, targets, uh, virtual applications in one of the more um, stable or structured or availability zone that you want data to specifically go to. Okay, data will go from the elastic load balancer to the EFB. I'm sorry, the EFS drive. Sorry, elastic file systems. So the elastic file system is a cloud storage service to provide scalable, elastic, concurrent data structure and with certain restrictions now to help encrypted file storage for the use of both AWS cloud services and on-premises resources, right? So it basically is able to help filter and configure and work with AWS data and on-premises data, bring them in and configure the data and then distribute it out. So once it gets distributed out, there's auto scaling that will also take place if it's a lot or large amount of data. Um, Depending on your setup, you may have multiple availability zones, which um, subnets have to be configured. That would basically be a process of what you would have. For us, that was part of the process that we had multiple availability zones. So when target data would come in, it would auto scale according to how large the amount of data, and if it was a small amount, it would be configured in that particular availability zone, right? The caching of Redis server, that would basically keep things nice and clean for us. Um, there was a master database as well, where records were brought in, all of the data were brought in, and keep the system level of information. And this was utilized with SQL, right? So this was a SQL server system that would basically house all of the records, all of the data. And so, um, for instance, login accounts, endpoints of data, linked accounts um, would be stored in these master data. And so, one of the things that I want to make sure that I brought to your attention, there are 4 system databases in SQL Server instances, right? You will need to make sure that you pay attention to the master, the model, the MS database, and the temp database, right? You want to keep an eye on it. Make sure, number one, you have all 4 and are utilizing all 4 of them for your AWS project. Okay, so this is um, a good example of AWS process flow using, again, big data coming across and making it scalable up and down for you. And hopefully you were able to gain some new information. And if you already knew it, hopefully it was a refresher for you. All right. So thank you again for joining Johnny Sanders with Truth and Life. Hit the like and subscribe, and I'll see you guys next time, okay? And remember, be good, but dare to be great.